So here's the problem. I really don't do anything physical. The only activity I do that even resembles a sport is ballet, and how are you supposed to apply physics to that? It's really pretty hard to figure out velocities and distance when everybody's going up and down and back and forth and all over the place, and fun as it might be to watch two ballerinas rush into each other over and over, alas, the collision is out. So I'm going to introduce you to turning and how it applies to this wonderful concept called angular momentum. And please note that everything you're about to see is a lot harder than it looks. Let's start with one of the most simple turns in ballet, the Shehnai, which means chain in French. The move itself is pretty basic. All it is a 3-step turn. In baby ballet, you're taught to do it like this. Okay, not only is that unattractive, it's also slow and frankly sort of painful to watch. Now let's see it done the right way. Do you see the difference? Please tell me that you see the difference. The difference is all in the placement of the feet. Do you see how my feet are closer together compared to the first time? I've decreased the radius of the turn, and by doing so, I've sped up and also increased the frequency of my turns. Well, maybe not per second, but also at least per minute, right? Anyway, that's what angular momentum is all about. So now let's look at another turn. This is called the pirouette. I have no idea what it means in French, but it's fun to say. This is one of the staples of ballet, and it again is all about foot placement. Here. See right there. The arc of the foot is supposed to cup the knee, which is not only graceful, but also as close as a ballerina can get without losing her balance. Let's say that my leg is 0.8 meters, so half of that would be 0.4 meters, which is the radius of this turn. Keep that in mind, we're going to use it later. Now, for argument's sake, let's see another example of my leg extended. See, clearly this is not the way that you're supposed to do the turn. It's really, really ugly, but this is just for argument's sake. Now that my leg is extended, it is a full 0.8 meters. Now, making sure that angular momentum and mass are kept constant, let's add velocity. In the original, the right way, my velocity was 2 meters per second. Now that I've increased the radius, I have decreased the velocity to 1 meter per second. See? Angular momentum. Ta-da! That's how angular momentum works. When you increase the radius, you decrease the velocity, and vice versa. And that is how you apply physics to ballet. And that's basically it.